this is an example of a doped semiconductor. We call it as a doped semiconductor because by adding some impurity in a pure form of a semiconductor, which is silicon, we can enhance or increase its conductivity. So as shown over here, we see there is a silicon atom, and each silicon atom has 4 valence electrons in its outer orbit. So for example, this silicon electrons has 4 electrons in its outer shell. This silicon electrons has 4 electrons in its outer shell, and all of these silicon atoms have 4 electrons in its outer shell. This is an electron. So electron in the outer outer ring of each silicon atom form a bonding with the neighboring silicon atom. So you see that there is a bonding. This is called as covalent bonding. This is called as covalent bonding. So there is a 1 electron from the top silicon atom and 1 electron from this bottom silicon atom that makes a bond. So all bonding happens here, but when you add an impurity, for example, take another semiconductor material such as P. So this semiconductor material is called as donor. Or why? Because this semiconductor material has 5 electrons in its outer shell as shown over here. So you see there is a red circle, big circle, and in the red you see that there is electron 1, electron 2, electron 3, this is electron 4, this is electron 5. So 4 of these electrons form a covalent bonding here, as you can see that. I can show you. This is the bond 1, this is the bond 2, this is bond 3, and this is bond 4. So it forms a covalent bond with the electrons of the neighboring silicon atom. But after forming the bonding, this one extra electron is left out. So that is called as, so there is an excess of electrons. So we have several such electrons when we add impurity to the pure silicon, and that is why, because this is called a doping process, and now the intrinsic silicon, which is a pure form of silicon, becomes an extrinsic semiconductor. So it becomes an N type of semiconductor. Why? Because we have added an impurity which produces extra number of electrons in the structure.